Alright, here is one of my free assessments. This assessment focuses on Chapter 24, or the refraction of light, which is also known as the bending of light. So what actually causes this magic to happen? Well, it's not really magic. It has to do with the speed of light slowing down. The speed of light is defined differently through different mediums. The speed of light in a vacuum or space is approximately 3 times 10 to the 8 meters per second, but the speed of light through water is approximately 2.26 times 10 to the 8 meters per second. This is because when light enters a new medium or different object, the wavelengths of light become shorter, and the velocity of a wave is equal to the wavelength divided by the period. Since the period stays the same and the wavelengths become shorter, the velocity decreases, which can be found right here. We can also find the velocity of the wave of light through different mediums if we know the index of refraction, because the new velocity is equal to the speed of light divided by the index of refraction. Just reverse these two numbers. You can simply do that. But how do they get these indices of refraction? Well, these were found by actually measuring the speed of light through different material through experiments. So let's say we measure the speed of light through plastic to be 1.5 times 10 to the 8th. We divide the speed of light by the velocity we found, and we get an index of refraction of 2, so the index of refraction of plastic would be 2. It's not really 2, but that's just per se. But refraction can only occur when light travels through a medium with a larger index of refraction. If a wave tries to pass through an object with a lower index of refraction, it will sometimes experience total internal reflection, which is where no light escapes through the medium. Now, of course, if you have a large enough angle shining the light would escape, but if you go smaller than that, then you experience total internal refraction, depending on the index of refraction of the medium you're trying to shine it through. So here's a problem where we have a flashlight located in air, and it's directed to a glass at an angle of 20 degrees to the normal, and the normal is just perpendicular to whatever your median is. And you want to find at which angle the light will be reflected, or the angle between the light and the normal and the opposite side. So the index of refraction of air is 1, or roughly 1, and the index of refraction for glass is approximately 1.65. So using Snell's law down here, which is the index of refraction of the first medium, or the original medium, times the sine of the angle between the normal and the light, equals the index of refraction of the second median, or the median you're passing through, times the sine of the angle between the light and that normal. So we set it up all down here. We have our initial angle is 20 degrees, n1 equals 1, n2 equals 1.65. We solve for sine of the second angle, or our angle we're trying to find, equals the index of refraction of the first median times the sine of that first angle over the index of refraction of the second median, or the median we're trying to go through. And if we take the inverse sine of that and put it all together, we'll have the index of refraction of air, which is 1, times the sine of the angle between the normal and the light, which is 20 degrees, divided by the index of refraction of this glass, which is 1.65, equals 12 degrees. So the light actually bent by 8 degrees, from 20 degrees initially, then going 8 degrees over to 12 degrees, so it looks like the light just moved. Now here's an experiment that I did to show the refracting of light. Here I have a flashlight on top of my awesome physics book and a drinking glass, and I'm just shining the light through the drinking glass on the door, and moving the flashlight out from behind the glass, and keep doing that back and forth so you can see the light going up and down, or just the light bending in general, and watch and be amazed.